Yeah, we're going to start by writing what we can figure out from these variables. So what does this tell us? It says that copper 2 hydroxide is going to react with, okay, that's a key word, hydrobromic acid. So we know that one compound is reacting with another compound. So Maddie, are these reactants or are they products?
The reactants.
Yes, and what told you that?
Because it says reaction.
Yes, I know that sounds silly, but sometimes our brain misses those things, like they glance over, especially when we're stressed on a test and we feel like we're a little bit behind and that timer's a little farther along than we like. We tend to skip important words. So when you see words like reacts with, things like that, it's really important we stop and take note of those. So we know copper 2 hydroxide reacts with hydrobromic acid. Those are going to be reactants, which means we're going to have to figure out the products. So we are going to go here. So dun, dun, dun. Darshan, why don't you build copper hydroxide for me? What does that look like? Copper 2 hydroxide.
So copper 2 means copper has a 2+ charge, and then hydroxide is a 1- charge. So you need 2 hydroxides to balance out the charges. So that's CuOH2.
Perfect. And what phase state is that?
I think that was, I gotta open the reference packet, sorry. But I think that was,
Take a look at the question. Look at the
screen. Solid, yeah.
You're good. Do you know what I love is that you totally went the correct route. If I wouldn't have said, you were about to pull out that packet, you're going to look at that solubility chart. And I love that that was the first place your brain went, because that means you do it all the time. And that is so good. I'm so happy you and your reference packet are so chummy, like should be besties, have a little bit of coffee stains, maybe a few tears, you know, girls, a little bit of mascara, you know, whatever it is on this reference packet that we just love and use all the time. It's very well loved. I like it, has character. All right, Charles, this reacts with tells it, oh wait, he can't be here today. He told me, okay, hold on. Samir, you're up then. So that reacts with told me it was plus. Can you build the hydrobromic acid for me? Samir. Are you here, Samir? Someone text him, be like, hey you, with the face. Boop. Ask him to unmute. Oh, wait for a sec. Is your mic working? That's the other option.
Smear's gone this week.
He's gone? He just logged in and he's gone?
He's gone. I'm sorry.
There's so much.
Sorry.
You disappeared, Samir.
I'm sorry. My brother was like, Samir,
issues.
This cat was like, okay, so we're fostering a cat, right? And it's like scratching up all the carpet, so I had to like deal with that.
A noble venture, but yes, cats are cray-cray. I have 2 very chill cats, and then the one that we are like holding right now, the third one that's like not ours, but it's in our house right now. It crazy. So I understand. All right. Can you build hydrobromic acid for me?
Yeah, HBr.
HBr. How did you get there? If you didn't remember how to make that acid, where could you look?
Probably reference packet.
Yeah, probably the reference packet. Always the reference packet, right? I'm going to look at that for some people because I know that acid naming was something we struggled with. Ooh, hold on. So we're going to need the naming chart, which is going to be sideways right here. So as you can tell, I've talked about this already. Hydrobromic acid tells us it's a specific rule, right? The hydro and the ic acid have to do with the rule, so we can cross those out. That leaves us with BROM, which then pairs with the ide of the rule. So if you don't remember what bromide is, you can look here and you can see that bromide is Br minus. If you didn't forget, it was just the element. So Br minus, and then we need 1 H to pair with it, and it's an acid, so it is aqueous. Good. So HBr aqueous. It's a 1-to-1 ratio. All right. Next up, Akshar. How do I determine what the products are? Akshar, are you here? Everybody's leaving me. Oh, whoa, what? Shut up. I'm so sorry. Now I feel bad. Okay, he's not here today. Oh my goodness. Guys, you gotta stop me before I say insensitive things. Good Lord. Okay. Evangelina, how do I determine products?
Repeat the question.
How do I find the products here? I have the reactants. How do I find the products? Back up one step. What type of reaction is this? Single replacement, double replacement, combustion, synthesis, decomp? What is it?
Double replacement.
Yes, so that means that this molecule and this molecule are going to replace each other. Hydroxide is going to replace bromine, and bromine is going to replace hydroxide. Okay, so what does our first product look like?
HCU.
So the H's and the Cu stay there. It's the hydroxide that's moving off. And so the hydroxide's breaking off and this bromine is replacing it. So instead it's going to be now Cu what?
Br.
Yes, CuBr. Now, how many bromines do I need? Copper is 2+, bromine is 1-.
2 bromines.
Yeah, so we need 2 bromines. The 2 individual bromine ions are what cause the 2 there, so we can balance the charges. And then what phase state is this? What phase is this? CuBr.
It's AQ.
Yes, because we see bromide salt, okay? And we don't have any coppers here as an exception, so this must be aqueous. So we end up with CuBr aqueous, and then that is going to be plus the other product. So good job, Evangelina. What's the other product? Yeah, we have CuBr2 already. What's the other one going to be?
Oh, HOH.
Yes, it's going to be the H paired with the OH, right? What's the other way we could have written that? Right? These are the same thing. I just wrote it like this to show you that the H is now with the OH, and that's going to be a liquid because that is a compound. Now, we have our reaction. So, Manahil, what do we do with every reaction? What do you have to make sure? Every time we have a chemical equation, what do we got to check? Are you here, Manahil? Let's see. Are you there? Hello.
Wait, did you call me?
I did.
Okay, sorry, I didn't hear you.
You're okay. So what do we need to do? We have a chemical reaction. What do we need to do to it though? What do we have to do with every chemical reaction?
You have to balance it.
All right, can you balance this one for me?
Okay. Wait, let me think about it for a second. So I think there needs to be 2, like in front of the HOH.
Okay. Where'd you get that? So yeah, so what I'm guessing is I'm gonna mind read you a second. You ready? So you said
Yeah.
that copper and copper were 1-to-1. So then you saw there was 2 OHs and 1 OH, which means we need to put a 2 here, right?
Yeah.
All right, what's next?
Put a 2 in front of the HBr because you just made 2 H's and then there's 2 Br on the copper. So
And that gives 2 and 2. So now we are balanced. Good job. All right, so that's this. So now, next step, I want you guys to try to set this up. I'm gonna give you about 30 seconds to a minute. You are gonna try to set this up because this is now, we've done this probably 10 of our days together. I want you to try to set this up. Then I'm gonna call on people to show me which parts you did first and last. So I'm gonna give you about a minute to work on it first. Okay? Give you a minute. About 45 seconds left. All right, next up, dun, 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 dun. Sangeet, where are you starting?
So first you have to underline the information. So you're looking for moles of salt and you have 15.84 grams of copper 2 hydroxide and
So what does moles of salt mean? Which one is it looking for? Which one in the equation? Our keyword is that it will form. So does that mean it's a product or a reactant?
it's a product.
Which product is the salt?
CuBr2.
Good. So the number of moles is our question. This guy is our question. Awesome. Now, what are our givens?
You have 15.84 grams of copper 2 hydroxide.
Okay, so that's 15.84 grams here, right? And then what's the other thing I'm given?
1 molar of hydrobromic acid.
Okay, so something we haven't talked about, we've talked about, we're gonna talk about it more specifically. When I see the word excess, I now know that this doesn't matter, okay? And I'll tell you why. We're not gonna use the thing that's in excess in our question here because all that's saying is that there's more than enough for it to react. So for example, if we have s'mores, say you have 2 graham crackers, I can't say words, graham crackers and 1 piece of chocolate, okay? But now you have like 1,000 marshmallows. The number of marshmallows doesn't matter because I only have 2 graham crackers and 1 chocolate, so I'm only making 1 s'more. The marshmallows are in excess, so we're not gonna calculate with the excess number. So as soon as you see excess, you know that that number is a red herring. It's like trying to get you to distract, okay? It's a distractor. All right. Yes, what the salt was. Yes, so the salt we knew, okay, so for this one, it says how many moles of the salt will form. So when I see the words will form, we know the salt must be a product. The definition of salt is a metal and a non-metal. Ions are salts. So the only one with a metal in it was this guy. We also know this is water, which is a compound. And then the hydrobromic acid, I crossed it out because it was in excess. And if something's in excess, we don't use it. It's not going to be calculated because we have more than enough. So it's not going to become a factor in our calculation, kind of like the marshmallow thing I just said, where we have way too many marshmallows. So I'm not even going to use marshmallows in my math. I'm going to use the graham crackers and the chocolate because that's what's limiting me. Same thing with hot dogs. If I have only one hot dog, but I have 100 buns, it doesn't matter how many buns I have. I'm only making one hot dog, right? Unless you just eat straight bun, which no, but it doesn't matter how many buns I have. The buns are in excess. So I'm not calculating with the buns. I'm calculating with the hot dog. Does that make sense? For the person that asked. Okay, I'm going to keep going. Next up. Dun, dun, dun. Izzy, what do I do now?
Can I start setting up the equation now?
Yes.
Okay, so like the little railroad track thing,
Okay.
and then 15.84 grams of copper 2 hydroxide on the top.
Okay. Now, we had another piece of information given, but what is our first step in stoichiometry? Good job, Izzy. I'm calling someone else. Magana, what's my next step? What's my first step of stoichiometry? What am I trying to convert to?
Moles.
Okay, so how am I going to convert to moles here? What information do I have?
The molar mass.
Yes, we have the molar mass. So where does the 97.57 grams go?
On the bottom, because you have to cancel out the grams.
Good, you got there before I could. Good job. And then the 1 mole will be on top. Awesome. All right. What is the next step? Maheen, what's the next step?
Would it be mole ratio?
Yes, mole ratio is the next step. Good job. You guys are so good. Okay, mole ratio. So how do I do that?
You would put 1 mole of copper 2 hydroxide on the bottom, and then 1 mole of copper 2 bromide on the top.
Yes, and we balance the equation because it's not always 1-to-1. In this case, it just happens to be. Awesome. Now, my last step is to convert to what? Jessica, what did the question ask me to convert to?
Normally you convert it to desired, but it's asking for moles, so you don't need to really add much to the equation because you're already going to get moles.
Yeah, so when we cancel everything out, grams canceled, moles canceled, we were asked for moles, right? So we are done. So all we do is put it in the calculator. Open 15.84 close, open 1/97.57 close, open 1/1 close, and that's going to give us a number, okay? Give me a scale of 1 to 10 on setting this up. Okay. You guys are doing great. If you have a lower number, I need to know that too. That's actually more important, so I know who to help. All right. So now we're going to dive into new material. So make sure right now you have your Unit 8 notes. And then for your reference packet, let me refresh so it takes off all my writing. You need this section right here, okay? This second page solution section. So right here, we have every equation you could possibly need for acid and base, okay? Because that's a type of solution. Now, usually the hardest part of acid and base calculations is the fact that we have to know our log rules to go between these guys. But what's amazing is that we already gave it to you. You don't have to know how to unwind a log. All you have to know is where to find it on your calculator and punch it in, okay? Because we gave you all of these equations. If you come to AP or IB, we are going to talk about unwinding logs. It's a very minor thing, and usually we start that at the beginning of the year to make sure we're really good by the end. But, and again, you guys should come see me in IB because IB is awesome, and we do lots of really fun, weird, crazy things that we don't do in normal AP because of organics, so it's super fun. But, yes, so we give you all these equations. So you're going to use this all day, literally all day. Okay. So first we're going to talk about the relationship between these things. Okay. So why do you think this looks like a square? Why do you think I did that? Dun, 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 dun. Trisha, why do you think this looks like a square?
I think her Wi-Fi went out.
Can you guys hear me?
No, Trisha's did.
Oh, okay. I was like, not again. My computer is so angry today. So angry. All right. I'll come back to Trisha. That's okay. All right. Why do you think this looks like a square then? Sonali.
I don't know.
Okay, let's take a look here at the formula sheet. We'll get you through it. Okay. Make this smaller. Oh, there she is. She's not even in here. I'll get her in a second. Okay, so take a look at these formulas. I'm going to make this smaller so it fits inside the box. No, 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 no. Don't do that. That's not what I wanted. Cancel. Okay. All right, so here are equations for acid base. Fits right in the square. Why might these be in a square?
Is it to go from one to the other?
Yes. So what I'm trying to tell you is if you know one thing, you can know anything else. Okay. So if I'm given hydroxide ions, there's a formula to get me to hydroxide ions. There's a formula to get me to hydrogen ions. If I get to hydrogen ions, I can get to pH. If I get to pH, I can get to POH or H+. So the most steps that any of these equations can be is 2 steps. For example, if I give you a question and I give you H+ and I ask for OH-, that is 1 step. If I give you H+ and ask for pH, that is 1 step, okay? But let's say I give you hydrogen ions and I ask for POH. I can't go directly through the center. There is no 1 step. So all I have to do is either convert to OH- and then go, or convert to pH and then go. So no matter what you're given, the most you can do is 2 steps. And if you're given 1, you can find out any of the others. They're all related. It's like a circle, okay? Because concentration is what determines pH. pH and POH have an inverse relationship, and then that can tell you the concentration and so on and so forth. It's a never-ending circle. We have a KW, that's the dissociation constant of water, and we're going to talk about that in a second. We have our pH and POH is equal to 14. That's like our pH scale. We've known that for ages. We knew the pH scale went to 14. There's a POH scale that's just opposite. That's all we're introducing. And then this is the equation to go back. And I already gave you the equation to go back and forth, but we can use this equation to go either direction, okay? So we're gonna start with 1-steppers and work our way up to 2-steppers. So we're gonna start with this one. So it says if the pH is 3.49, what is the POH? So when I'm looking for formulas, how do I decide which one to use? Renee.
You can check which units are in the formulas.
Yes, I go to my formula sheet and I say, hey, which formula has everything in my problem and doesn't have more than 1 missing, right? If you have more than 1 missing, you can't use it. But if you only have 1 variable missing, you can use it. So let's go back to our formula sheet. I have pH. I need POH. Carter, so which formula am I using? Off of here.
So we're trying to get to the POH.
Yes, we have pH. We need to get to POH. Which formula looks right?
So you would add the pH to the POH.
Yes, it's this one. We have pH. We need POH. There's no other variables missing. It works for us. So the equation we are using is pH plus POH is equal to 14. So if I want to find POH and isolate it, I subtract pH from both sides. So I know that POH is going to be equal to 14 minus pH. Now you don't have to rearrange it first. That's a habit that I do because complicated chemistry, I don't like having all the scientific notation in there when I'm moving things around. So this is a habit I've built from upper level chemistry, but I'm trying to communicate it to you now so as you go up in your science classes, you get used to it. Lucas, what do I do now? I have the formula. How do I solve?
Well, now you plug in the pH value, which is 3.49.
And what will that give you?
That will give you 11.41.
Almost. So 14 minus 3 is 11, and then I'm going 0.49.
Oh, yeah. Sorry.
No, mental math games are fun. It's a good skill. It's a good skill to have. POH is 10.51. Now, here are some questions that I have. First, Gus, is this acidic or basic solution? Are you there, Gus?
Basic.
So you said basic because this is 10.51, right?
Yes, ma'am.
What did we find?
Pot.
No, we did not find pot. That would be a police officer knocking on my door. This is POH. Okay. So we found.
My bad.
No, you're fine. I thought it was funny. So POH, our scale that we've been using is based in pH. It's the pH scale. So what you've learned as 1 to 7 to 14 base acid is based off this number. So POH is the opposite of pH. So use pH when you're figuring out if things are acidic or basic. So I'm gonna ask again, do you think it's acidic or basic? Go ahead, Gus. Would you like to revise your answer?
It's acidic.
Yes, because the pH is less than 7. We have two different ones now. Okay, so this is an acid, which means that the hydroxide ions are in greater concentration. Okay, so next up, Victoria, does that mean there are no hydroxide ions?
No.
No. What does that mean? What does acidic mean in terms of ion concentration?
It just has more hydrogen atoms.
Yeah, he has, so what it means is this solution, it has more hydrogen ions than hydroxides. There are hydroxides, but if I paired every single one of them up with a hydrogen, there would still be hydrogen left over. And that's what makes it acidic. So just trying to make sure that we drive all those acid-base points home and review them constantly, okay? Scale of 1 to 10 on this problem. Okay.
I think Esty has a question. She raised her hand.
Oh, I see it. Yes, I did not see that. Yes, Esty, what's your question?
I didn't mean to.
Oh, okay. That's okay. So I will lower hand. There you go. Yeah, no, you're good. I didn't see it. And thank you guys. If you ever see that, call it out because there's a lot of little squares and it's easy to miss that stuff. Okay. I'm also trying to monitor the chat and everything else as we go. All right. And this next one, it says if the hydroxide ion concentration, so to be clear, that is how we read this. So when you have hydroxide ion concentration, okay, those brackets are what I'm reading as concentration, and whatever is inside of it is the concentration of. So this is if the concentration of hydrogen ions, that's how you say that when you read it, okay? The concentration of hydrogen ions was 4.76 times 10 to the negative 4 molar. Concentration will always be molarity, because it's about concentration in a liquid, okay? It's asking what would the pH be? So we are going from hydrogen ion concentration to pH. So we're gonna look at our formula sheet. I'm gonna erase this stuff. Go back to draw. All right, next up. Dun, dun, dun. Corey, how am I going to solve this one?
Okay, one sec. Hold on. I have to refresh my page because the unit 8 and stuff didn't work. Okay, so you're gonna do the negative log of 4.76 times 10 to the negative 4th.
Yeah, yes. So we're looking for pH and we have concentration. So our equation that has pH isolated that also includes hydrogen ion concentration is this one. So we have pH is equal to the negative log of the hydrogen ion concentration. So all we're doing is plugging this number in right here. So when we plug it in, I want everyone to practice plugging in logs because calculators are stupid. We don't want to lose things to stupid calculators. So negative log of the 4.76 times 10 to the negative 4 molar is going to be equal to what? What does our pH end up being?
Uh, 3.32.
Yes, 3.32, and that is what you should have gotten, okay? So next set of questions is making sure we understand acid base like we've been doing. Thank you, Corey. Celine, is this acidic or basic? Celine, are you there?
Acidic.
Yeah, it's acidic, which means which concentration is higher, H plus or OH minus? Hydrogen ions or hydroxide ions?
H plus.
Yes. Hydrogen ions are winning. It's higher hydrogen ions than OH minus. Scale of 1 to 10 on this problem. Okay. Next up, it says if the hydrogen ion concentration was 4.76 times 10 to the negative 4, so we didn't change that. If the hydrogen ion concentration was 4.76 times 10 to the negative 4, what would the OH minus concentration or hydroxide ion concentration be? So on the wheel, Esty, which equation should I use?
Well, we're looking for the OH and we're coming from the H plus. So use the H plus times the OH minus equals 1 times 10 to the negative 14.
Yes. So we're going to stop and talk about this one for a second, guys. And that was perfect. So we know the Kw is equal to the hydrogen ion concentration times the hydroxide ion concentration. And that is equal to 1 times 10 to the negative 14. Okay. So, Bob, does anything about this equation look familiar other than the variables?
Other than the variables. Oh, I guess the exponent.
Okay, why does this number matter in acid base? Why is this such an important number? When have we seen it? Since like elementary school?
It's on the tip of my tongue and I don't know why.
So let's look at the formula sheet. Well, last class we were talking about, remember we did the Google Slides and you had the colors on the bottom? What was that? What was that on the bottom where we were determining if things were acidic or basic or weak acid or strong acid? What was that?
Oh, the pH scale. So, is it the highest number on the pH scale?
Yeah, so this is what we base the pH scale out of. So the whole thing I'm trying to make a point of, guys, is that it wasn't like these old dead white guys were all like, you know what my favorite number is? I just love 14. So why don't we make the pH scale 14 and we'll just scale it all to 14 because 14 is such a fun number. Like that's not what was happening here. What this is that anytime you have a glass of pure water, like your water bottle, your water sitting in front of you, you know, anything else, 1 times 10 to the negative 14 of those water molecules are dissociated by nature because water also pulls on itself. So that small number are always split up. Okay, and that's what we're basing the pH scale off of is the dissociation of water. Okay, so there's an actual scientific purpose behind it. It wasn't like we just picked 14 out of the air one day, all Valley Girl like, right? Not like, it wasn't like Elwood's decide this. Okay, so this is the pH scale. It's based on the dissociation constant of water because these two things made up have to equal 14. So this one and this one's exponents and the numbers will add up to the 4 or multiply 14. K is the dissociation constant, and we'll talk about that in AP and IB and in equilibrium later. But basically when a reaction is reversible, like water splitting up and joining together, there's a rate at which that happens or an amount that happens. So the W is for the water, K is for dissociation. That's how in K, we have Ka, we have KEQ, we have Kc, we have Kw. There's lots of things at K. So K is just a constant that has to do with dissociation. And then the letters tell you what we're dissociating. And in this case, it's water. Yep. So it's all based on water. So we're going to pause that. We're going to go back and we're going to press play on our problem. So we need OH minus. So let's isolate that. So the OH minus is going to stay, right? Concentration, hydroxide concentration. To get the other one by itself, we have to divide off the H plus from each side. So we get that our equation is OH minus, or hydroxide ion concentration, is equal to 1 times 10 to the negative 14. These parentheses are very important. Over the hydrogen ion concentration, which we got from here, as 4.76 times 10 to the negative 4. When you divide those, you should get a number. I want everyone to practice putting this in your calculator and put in the chat what you got, okay? Put in the chat what you got. I want you to check and make sure your calculator skills are on point because not only is there fractions, there's groups of scientific notation with negative exponents and calculators are dumb. So there's lots of wiggle room here. I'm gonna wait until at least half of you have it in the chat. Yes, I see a lot of you had it now. Good. So if you do this right, you should get 2.10 times 10 to the negative 11. If you got a different exponent, it means that you somehow missed the negative signs or did not put the parentheses in the correct spot. Okay. All right. So this one's going to be slightly different. Okay. We're going to amp it up. So we've been doing 1-steppers. Now we're going to go to a 2-stepper. So Wajiha. This says the hydroxide ion concentration is 3.75 times 10 to the negative 3. It's asking what would the pH be, okay? So help me develop a plan to solve this using these equations.
Okay, so you can go from hydroxide to hydrogen, like that top like arrow, yeah.
You want to go to hydrogen?
Yeah, and from there you can go to pH.
Was this the only option we could have done?
No, you could have gone to POH and then to pH.
Yes. So we're actually going to do both. I'm going to do both with you guys. So you can see that they both come out to the same thing. If you want to work ahead, you can work ahead. We're going to start with hydroxide ion concentration, and we're going to do what she said. We're going to go to hydrogen ion concentration. This is like planning our attack here, to pH. The other option you had was to go from hydroxide ions to POH to pH. Okay, so I'm going to cut those in half. We're gonna, oh, that's a really bad line. I'm so sorry. My OCD will not allow that. Okay, hold on. No, okay, I'm just gonna give up. I give up already. This is terrible. All right, so we're gonna solve these. So, all right, Sneha, start me with this one. How would you start with the blue method?
So you would start with 3.75 times 10 to the negative 3.
Yep. Which equation will we start with if we're going to hydroxide ion concentration first?
Would we start with the blue one?
Yeah, it's the same start point. So we would start with the fact that we know 1 times 10 to the negative 14 is equal to hydrogen times hydroxide, right? We already know hydroxide, so that's what we're dividing off on both sides. Oh, why did I do that? Pretend I did that right. Okay, so these cancel. So I get the hydrogen ion concentration is equal to 1 times 10 to the negative 14 over the 3.75 times 10 to the negative 3. And when I do that, I get a number. What number do you get?
I'm putting it in my calculator.
You're good. People, feel free to put in the chat, guys, if you want to check your work.
Would it be 2.67 e to the negative 12?
Yes, 2.67 times 10 to the negative 12. Okay. Now we have the H plus. Shanmati, how do I get from H plus to pH? So we did this step. We need to do this step.
It would be negative log H plus equals pH.
Yep, negative log of H plus, which is the negative log of 2.67 times 10 to the negative 12. If you have a TID4, you can use second ants and plug that in, which is super nice. So we get the pH is equal to what? Should be 11.57-ish. You do it right in your calculator. All right, method two. Method two. If I go from hydroxide ion to pH, that is where I would use the same idea of pH is equal to the negative log of the hydroxide ion concentration. So I would get POH is equal to the negative log of 3.75 times 10 to the negative 3, which would then give me a POH of 4.25. So from there, I did the first step. The second step is to go to pH. So wait, 4.25, that's not right. What would it be? Can you guys put that in? That just looks wrong to me all of a sudden. Hold on. Went off memory and it doesn't look right. .42, yeah. Yeah, I was like, I don't know where I got that number from. Oh, do you know what? I do know where I got that number from. Hold on, spoilers. So 14 minus POH is going to be equal to pH when you rearrange the equation. So pH, when you do that, is going to end up being 11.58. So notice how the numbers turned out almost exactly the same. It doesn't matter which one you use. Okay. All right. Try this one, guys. And I want you to type your answer into the chat. I'm going to wait for half of you to get done. I'm not going to do any to start. Try it and type your answer into the chat when you get it.
Can you pull up that boxy thing again?
The boxy thing? Oh, the...
Yeah.
Here, do you know what I can do? Hold on. Pause. If you guys like that, copy. Go back down here. Paste. Okay, and I'll make that a little smaller. Put it to the right. Boom. Better?
That's perfect.
Okay, I see some answers trickling in. The ones that have trickled in are correct. I'm waiting for a few more because I only see about 5. Okay, yes. So this is 5.62 times 10 to the negative 5 molar. You could have done that by going from pH to H plus to OH minus like this, or you could have done that alternatively by going from pH to POH to OH minus like this. Both would get you to the same answer of 5.62 times 10 to the negative 5. This is basic, which means the hydroxide ions are higher and winning. Okay, so that is what we had today. Do we feel better now that we've done some calculations together? Yes, no, maybe so? All right, here's what we're gonna look at now. I want everyone to pull up their Canvas. Okay, so under your modules, there's a couple things. First, do not forget, if you want to retake your test, you have to schedule with the testing center by Friday. Like I would make the appointment now and then get everything done before you actually show up. So that way you can take your Unit 7 test again for up to an 85. That would help a lot of you. For this week, these video notes are what we're going over next class. And we're going to be looking at these. The QC 8.3 is due today. And the rainbow concentration is due today. These guys are going to be due after next class. Okay. So I also in Pivot I know it's for next week, but I put your titration lab and made it open. So if you are working ahead through those notes and you get through these titrations and you feel confident, then you can go ahead and try to start the lab. Now there's multiple attempts on each question. So if you try an attempt and you're just like completely lost, then you can stop and wait. All right, so I got a question about the testing center. So literally how I find it is like this, guys. Allen ISD Testing Center. And it's like, oh, here's the testing center. It's a website and you schedule using this Calendly link. Okay. You guys are virtual, so you will follow these procedures. Okay. The module will open up when you've completed everything within the module. Okay. All right. Are there any other questions? Okay, guys, it was nice to see you again. I missed you. Well, seeing some of you, most of you are black squares, but I still missed your black squares, I promise. Okay, so I will see you guys next class. We're going to talk about strong, weak acids and things like that. Okay, bye, guys.
Take care. Thank you.
Bye. Have a good day.
Miss Longley, could you please go over QC 8.3 for me? I just have a couple things.
Before I do that, what are the other questions we have? I see some people hung out.
I want to go over my text, if that's okay.
Okay, that's totally fine. Just give me a sec. Samir, Trisha.
QC 8.32.
Okay, and then Samir, we chillin'? What I'll do is I'll pull up a preview attempt and we can work through those together, and then y'all can go take. Do you guys need another attempt? Did you use them all already, or have you just tried one and was like, ooh, no?
Well, I have 2 left.
Okay. So hold on, I'm pulling it up. Preview. Here. Okay. No, no one wants to see themselves. Stop. All right. So it says complete the following calculations, blah, blah, blah. All right, so a solution has a hydrogen ion concentration of 2.37 times 10 to the negative 3. What is the OH minus? So how would we set this up, guys? Where are you? You can go ahead and stay unmuted if you want, since it's just so few of us.
So I'll have to go get my packet up again because I switched out of it to get to the QC. Sorry.
So you might have to adjust most of food. Okay, there we go. So
you have to use the formula on the bottom. That's the hydrogen and the hydroxide is 1 times 10 to the negative 14.
Okay, yes. So they gave us hydrogen. So we are going to divide off the H plus. To leave us with OH minus. So we get OH minus is equal to 1 times 10 to the negative 14 over 2.37 times 10 to the negative 3.
There should be like 4.22 times 10 to the negative 12th, I think.
What'd you get, Celine and Trisha?
I got the same thing.
Yep, then that would be it. If you guys are in consensus, I haven't physically typed this in, but this is the setup. So if you put this in, that would be correct. Okay. All right, next question. A solution has a pH of 1.88. What is the pOH? So what are we going to do here?
Subtract it from 14.
Perfect. All right. We have, yeah, if you do 14 minus 1.88, you'll end up with 12.12. And that'll be the pOH, right? Mental math, maybe? Oh, I'm so tired. All right. So next If we have the hydroxide ion of 5.0 times 10 to the negative 4 molar, what is the pH? So this is going to be another one of those two-steppers. So let's make a plan, right? Because we know it's a two-stepper because we have a concentration, and this is a P, but this is an OH and this is an H. So we know we have to get to H before we can actually find the other, right? So what are the ways that we could solve this?
You could do OH to you could do OH to H and then H to pH, or you could do OH to POH and POH to pH.
Yep, so or you could do OH minus POH. Okay, so if you did it this way, you would do the hydroxide ion concentration to POH. You know, POH is equal to the negative log of OH minus, right? That'll give you a number, and then you subtract that number from 14, and that'll give you there. So that's the idea. That's the method. Or if you did this, you would use that 1 times 10 to the negative 14 again, right? Divide off the H, and that would give you, sorry, divide off the OH minus, and that would give you the H plus, which we know that the pH is equal to the negative log of H plus. So either way, it's a two-stepper. Okay, does that make sense? Is this what you were doing before, or are we kind of lost in the middle?
Oh, this is what I was doing, but some of the answers came back as wrong. So I think I just plugged them into the calculator wrong. That's
Well,
me.
hold on 1 second. Let me do this too, because if you're doing this the exact same method, Trisha, how is this going for you? Is it making sense? Is it helping?
Yeah, I just got one wrong and I wanted to do another attempt.
Okay, are you already out of all 3 attempts?
Yeah.
Okay, let me add one for you then. All right, moderate, because you stayed after and asked. Okay, let me do this. I'm gonna stop sharing. Okay. Okay, thank you for coming to tutoring. There's one attempt. And then for Darshan, I want to make sure it's actually programmed correctly too, because I haven't worked with them. Okay.
It says for me different correct answers than the ones that I got, so it's not. I'll let them believe it's a computer error.
I think it's a computer error. Let me see.
No, I don't think it's a computer error because it says.
Okay. All right. Well, thank you guys for staying after. Hopefully that helps. You still have attempts. Trisha has her other one, and you guys are good to go. Okay. I know I got to stay for Celine, go over her test.
Thank you.
No problem.